Friction occurs due to interactions of surfaces at a submicroscopic level. The more my mountain bike weighs, the greater the normal force, and thus the greater the friction. Well, why can I easily ride up this gravel 2-track when it's snow-covered, but not so easily on ice? Well, the answer: friction is not only determined by normal force, but by the composition of the materials in contact with each other. These differences in compositions are expressed as coefficients of friction. The coefficient of friction for the snow-covered gravel is much greater than that of the ice in contact with my mountain bike tires. I can hear my tire sliding a bit. Well, you can see from that little clip right there that I was able to climb at least up to my camera on my mountain bike. Yesterday wasn't even a thought. I could barely walk my bike. I'm going to try to make a full run up the whole hill right now. The friction involved with mountain biking up this icy trail isn't as simple as we make it sound. Tires aren't designed to slide, but to roll. There really are 3 types of frictions at play here. A static friction, let's say the bike was just lying on the trail and not moving, a no motion, stationary. Static friction is when opposing forces are in equilibrium with each other. Then there's kinetic friction. Let's say the mountain bike starts to slide. This friction is friction that impedes motion already in progress. And then finally, rolling friction, which is caused by the interactions between a rolling surface over another surface, as in the tires rolling. These rolling frictions involve many complex interactions and make this a little bit more of a complex issue than we may make it sound. A somewhat regular cadence, keep the back tire weighted, and your recap. Here's your mountain bike tip for riding up this icy trail. To maximize your friction, you want to start pedaling slowly. This helps to convert your static friction to rolling friction, thus avoiding the sliding or the kinetic friction. And to stop, just the opposite. You want to stop slowly. You want to convert that rolling tires friction to static friction, again bypassing the kinetic or sliding friction. The minute that back tire starts to slide out or your front tire starts to slide out, it's a pretty quick trip to the ice. Alright, you've seen me climb up this icy hill using my spiked tires, which again functionally increase my coefficient of friction. Notice that I still have a little bit of trouble with balance because there is a bit of slip every once in a while, so I'm constantly making adjustments to overcome those forces in the direction opposite I want to go. So if you'll watch the video closely, you'll see there is a constant battle to readjust my center of mass and to use my front tire to keep my balance. We're going to go ahead and show you a video clip here a little bit later that shows a very similar issue with coefficient of friction on a downhill bike race where the course got muddy due to rain. And again, you can recognize again the fact that mud on a course with acceleration due to gravity pulling you downward is going to functionally reduce your coefficient of friction.